We already decided that picking an apple up off the floor and putting it on a table takes about 1 joule of work. 1 joule is not a lot of energy. Let's look at other common situations and get a better sense of how big a joule is. We will do an example with each of the energy flavors we have defined so far. A 50 kilogram boy is running with a speed of 8 meters per second. What is his kinetic energy? His kinetic energy is 1/2 of his mass times the square of his velocity. So half of 50 kilograms times 8 meters per second squared is 1,600 joules. A 4 kilogram textbook is placed on a shelf 1.8 meters above the floor. How much gravitational energy exists between the block and the earth? The gravitational energy is the mass times the local gravity times the change in height. 4 kilograms times 10 newtons per kilogram times 1.8 meters is about 70 joules. It takes 12 newtons to stretch a rubber band 23 centimeters. How much elastic energy is in the stretched rubber band? The elastic energy is 1/2 of the elastic constant times the stretch squared. I'll keep the half. The elastic constant is the force per stretch. In this case, it would be 12 newtons over 0.23 meters. The change in length is also 0.23 meters. I have to square that. That gives me 1.3 joules. That's not very much energy at all. Last one. A bike pump uses 200,000 newtons per square meter of pressure to increase the volume of a tire by 0.004 cubic meters. How much pneumatic energy is in the tire? The pneumatic energy is the pressure times the change in volume. 200,000 newtons per square meter times 0.004 cubic meters is 800 joules. Done.